Welcome to Read in Motion. Our video will look at an important paper in the American Journal of Respiratory Cell and Molecular Biology. Here, we discuss lack of S1PR2 in macrophage ameliorates sepsis-associated lung injury through inducing IL-33-mediated type 2 immunity by researchers from Zhejiang University School of Medicine in Hangzhou, China, and the Faculty of Medicine at Imperial College London, UK. Sepsis is a major cause of death worldwide, often resulting from progressive organ failure, particularly in the lungs, where the mortality rates can approach 50%. Type 2 immune response plays a key role in regulating inflammation of the airways, and it may play a significant role in modulating sepsis-induced inflammation. But how does this happen? Sphingosine 1-phosphate receptor 2, S1PR2, is expressed by macrophages in the lungs. S1PR2 is known to influence type 2 immunity in lung diseases like asthma and pulmonary fibrosis. To explore its role in sepsis-induced lung injury, researchers investigated how S1PR2 regulates type 2 immunity in this context. They compared 18 patients with sepsis to 15 healthy controls. The type 2 innate immune responses, especially ILC2 cells and CD16- eosinophils, were significantly increased in the blood of septic patients 24 hours after diagnosis. This was indicated by higher plasma levels of interleukins IL-4, IL-5, IL-9, and IL-13. Interestingly, higher type 2 immune signatures in septic patients were correlated with higher oxygenation and lower organ failure scores, suggesting that the host response of less severely ill patients was characterized by stronger type 2 responses. S1PR2 mRNA levels in monocytes demonstrated a negative correlation with the type 2 immune response. To further understand S1PR2's role, the researchers inactivated the gene in a mouse model, comparing these S1PR2 deficient mice with wild-type mice subjected to a cecal ligation and puncture model of sepsis. They found that S1PR2 inactivation increased eosinophils, ILC2s, M2, macrophages, and the expression of type 2 interleukins, IL-4, IL-5, IL-9, and IL-13. The promotion of interleukins was dependent on IL-33. Additionally, S1PR2 inactivation led to an increase in macrophage-derived IL-33, which in turn boosted the type 2 immune response in the lungs. In conclusion, S1PR2 inactivation during pulmonary sepsis promotes IL-33 release from macrophages. This, in turn, increases the release of type 2 interleukins, which alleviate lung injury. These findings suggest that targeting S1PR2 could have potential therapeutic value for treating sepsis. For more details, please read the article by Dr. Gong and colleagues. Thank you for watching Read in Motion.